And by the way, if you're coming to the hackathon and you have coffee requests, I'm buying the coffee today, so send those to me. I'm getting we have several Keurigs that are going to be there, so I'm buying K cups. So if you have a, huh? Well, you can bring your favorite with you. Otherwise, we'll provide them. So message it to me. I'm not going to remember. You send me what you want, and I'll try to find a variety pack that has that in it.
Is it going to be in this room, or is it going to be in those?
It's the whole area.
Oh, the whole
yeah.
area. Okay.
I think I'm going to have my team set up in here, but there's no reason why you can't also be in here. But
so how do you have? Yeah, how do you have 2 teams?
Well, we didn't have enough team leads, and I figured that maybe I could swing it.
There's not going to be well, I guess you're not one of mine, so I won't say conflict of interest.
So there's a team with you on it.
There's 2 teams with me on it.
So like, how does that work for everybody else?
More than likely, my teams aren't going to win.
All right.
But I'll make sure they get prizes anyways. Yeah. But I'm not writing all the code. It's a learning experience for them. I mean, Grace is writing all the code, right?
Sure.
Nailed it. All right, so we talked last time about this merge step, and really the tricky part in the merge step isn't really the merge process itself. It's in the copying it back part, right? Because what we do is we create a list. It's just a plain Jane starter list. So here, let me just empty this guy out real quick so we can kind of go through this step again. All right, so now in a strongly typed language like a Java or a Swift or a C#, we would actually define this as a 6-bucket array. That is an array big enough to hold all of these elements. Okay. Now, in Python, our arrays are called lists, and they actually grow. We don't set the size to start with. So this guy will start off as an empty list, correct? We'll just have a nice little placeholder to hold our answer, okay? And as we add stuff, we will add things onto the list. So here, we'll kind of drag this down here. We'll use it as a placeholder. So we're going to start off with this little guy here, right? You know, the empty list. Okay, there's nothing in there yet. And we're going to have 2 little variables. Maybe we call this guy pos1. And we call this guy pos2. All right, and these are going to represent the beginning of each of our 2 partially sorted lists. Because remember, when we do the merge step, we've returned from our 2 different recursive merge calls, right? Or merge sort calls. So we know that the left half is sorted in and of itself. We know the right half is sorted in and of itself. Now we need to merge those 2 together into a single sorted list, and then the difficult part is copying that stuff back into the original list. Okay? And it's not so much difficult as that requires some legitimate thought to make sure we don't overwrite the wrong portions of our original list. Because I might be currently merging buckets, 3 through 8, let's say, in my original list. So I don't want to mess up stuff, 0 to 2, and I don't want to mess stuff up after 8. So I want to make sure when I copy my sorted answer back in, I copy it over buckets 3 through 8 exactly. All right? But when this guy, the guy I'm building before I do the copy, he's buckets 0 through 5 or whatever. Okay? So we start off, we ask the question, is pos1 a legal position? Is it pointing somewhere that's still on my first list? It is. Is pos2 a legal position? Yes, it is. So they're both legal positions, therefore we need to compete against each other. Which should come first, the element at pos2 or the element at pos3? The element at pos2, correct? So we will tack on, go ahead and delete this guy now, the element from pos2, and then we'll increment pos2. Are they both legal positions? Yes, they are. Which should come first, pos1 or pos2? Pos2. So we'll tack on whatever's at pos2, and then we'll increment pos2. Are they both still legal positions? Yes, they are. Which should come first, pos1 or pos2? Pos1. So we'll tack on what's at pos1, increment pos1. Which should come first? Are they both legal positions? Yes, which should come first, pause 1 or pause 2? Pause 1. We'll tack on what's at pause 1. Increment pause 1. Are they both legal positions? Yes, which should come first, pause 1 or pause 2? Pause 1. We'll tack on that guy. Increment pause 1. Are they both legal positions? No. So which one is illegal? Well, then we have to ask the question. If pause 1 is a legal position, then he's the winner, but he's not. Therefore, pause 2 must be the legal position. Or if he's a legal position, then we take him as the winner. So there's our 7. Increment that. We know we're done when both of these guys are illegal positions, right? They've both walked off the end of our list. Okay? Similarly, we could have kept a count and known that we needed to do this 6 times. And once we've hit 6 winners, we know we're done. You could have gone about it that way too and done this as a for loop. All right, and when we implement it here in a minute, we can make that call. Any way you cut it, we're going to go until pause 1 and pause 2 have walked off the end of their lists, or we've done it, in this case, 6 times, and those are the exact same things, right? That equals the same thing. All right, so now I have this brand new list that I created here that has the stuff in order. And I need to copy that stuff back in, and I'm just going to actually go ahead and I'm going to create a fictitious portion of our list here. So let's say this is 3, 4, 5, 6, 7, 8. All right. Because this is an example of the situation where it's difficult. So in my original array, the elements that I'm overwriting now, that I've merged into the secondary array here, live in positions 3 through 8. But if we look at this guy down here, this list is indexed 0 to 5. It was a fresh list that I just added some stuff to, right? So I have a list that's just sitting here that's indexed from 0 to 5 like any normal list would be. And I have my stuff in order here, but I need to copy whatever's in bucket 0 here over bucket 3 here. Whatever's in bucket 1 over bucket 4. Bucket 2 over bucket 5, so on and so forth. Does that make sense? I'm copying this stuff over the portion of my list that I'm actually sorting right now. That's the tricky part to this, to make sure that we index through both of these things. So what I would probably do is I would probably go ahead and I could reuse one of these variables if I want, or I can go ahead, now maybe I'll just call a variable just pause. Okay, so I have a variable here called pause. So I'm going to keep track of pause in this list. And then I'm going to create a for loop that's going to take me on a voyage between 3 and 8. Okay, so for I in range 3 to 9, non-inclusive. All right, that is begin for this particular loop through, begin to end plus 1. All right, maybe that'll be our variable I. So I'll have a for loop. I'll just let it go. Nailed it. So we're going to have a for loop. It's going to take I from 3 to 4 to 5 to 6 to 7 to 8. And then I'll increment pause. I'll start pause off at 0, then 1, then 2. So what I'm going to end up doing is I'm going to set my original list, maybe it's called LST or something like that. LST at bucket I equals temp list at bucket pause. So I'll copy over the 1. Increment I, increment pause. LST at bucket I gets temp list at bucket pause. There's the 2. I increments with the for loop. We manually increment pause. LST at bucket I gets temp list at bucket pause. Here's our 3. I increments with the for loop. Pause increments manually. LST at bucket I gets temp list at bucket pause. I increments with the for loop. Pause increments manually. LST at bucket I gets temp list at bucket pause. I increments with the for loop. Pause increments manually. LST at bucket I gets temp list at bucket pause. Just happen to be the same number. Our loop has now ended, right? And we have successfully copied our temp list back over to our original list, to the portion of the original list we were interested in. That makes sense what we're trying to do here? All right, so for those of you who, I know I asked how did this go, and there was a lot of groans, right? Okay, how many of you drew pictures first? Okay, so we have a sorta and a kinda. The rest of you, that means didn't draw any pictures? You just kind of sat down and tried to wing it? It didn't go so hot? It didn't go so well? So you didn't draw pictures. Don't you find it fun to draw pictures? Yeah, and you see I draw pictures often in class. Mostly because I'm basically a 5-year-old stuck in an adult body, but it's important, okay? So I'm not just drawing these pictures. I'm reiterating this multiple times, right? But until everybody says, oh yeah, I drew my pictures, you bring in your little artwork, we'll hang them up on the wall. We should maybe do that. It's like fridge art, right? Okay. You have to draw pictures as you're doing this stuff. The second our algorithms start getting more complicated than like printing out 1 through 10, when we're doing this manipulation of stuff, if you don't draw pictures, you're going to have trouble doing this stuff for a long time. Eventually, what will happen is for a problem like this, you will get to the point where you'll feel like, I'm drawing the pictures, but I didn't really need to. If you start finding that it's boring and not useful to draw the pictures for that level of problem, then you know you've kind of graduated to not have to draw the pictures for that problem. But the point is that you're actually still drawing the pictures. You're just kind of doing it in your head. You know, you can visualize the solution to the problem, but you're not at that point yet for at least most of you, right? And most of you need to give yourself a visual step-by-step instructions for this. In fact, you probably should have done it in 2 pieces. So we should have paused after we did that first thing where we used pause 1 and pause 2 just to build that temp list. Then once we have that guy and we've proven he's good, then do the new picture for how do you copy that guy back over to the right place. All right, so let's go and write this, but draw pictures over and over and over again. I should start requiring you to submit screen captures of your pictures. Whether you draw them by hand, just take a picture of it. That would be actually fun. Require pictures. Okay. So let's get rid of these guys here. Okay. So right here is where we're actually doing that merge step, correct?
Yes.
All right, and we created 3 different variables. We created a pause 1, a pause 2, and we also then created a temp list, a list to hold the answers in, right? So let's go ahead. I'm going to take out this time to merge thing. So we're going to go ahead and we're going to create our pause 1. So we'll say pause 1 is going to be equal to begin. All right, that's where it's going to start off. It's the beginning of the left half. Now we want pause 2 to start off at the beginning of the right half. Where is the beginning of our right half? Middle plus 1. This guy right here. So we'll say pause 2 is equal to middle plus 1. So now I have those 2 variables set to the beginning of our 2 lists. Okay? Now, when is pause 1 illegal? When is pause 1 walked off the end of his half of the list? Yeah, when it's greater than middle. Middle's legal, right? Middle's the last legal bucket in the list. So pause 1 has walked off his list when he is greater than middle. When has pause 2 walked off his list? When he's greater than end. Greater than end, because end is our last legal position, right? Yeah, so we have greater than middle, means we're in a legal position in the first half, and we have greater than end, which means we're in a legal position in the second half. Keeping in mind that at this point in time, we don't know where in the big array we are. We just know our confines are begin to end, whatever those values happen to hold. Okay? So, we're going to have several questions here. So, we're going to keep going as long as pause 1 and pause 2 are both legal positions. Correct? So, while pause 1 is less than or equal to middle, and pause 2 is less than or equal to end. While both of those expressions are true, we still have comparisons to do. Everybody agree with that? So that's that Boolean expression that says if pause 1 is legal and pause 2 is legal, we still have stuff to do. Now, what happens if pause 1 becomes illegal and pause 2 is still legal? Don't we still have stuff to do? So this and is actually an or. We want to keep going as long as either of our positions are legal. They might both be, both is fine, but as long as at least one of them is pointing at a legal position, we want to keep trucking. That make sense? So now when we're inside this while loop then, we do not know for a fact that both of them are legal. We know that at least one of them is legal. So now we need to ask some questions. If they're both legal positions, we got to compare them to pick the winner. If they're not both legal positions, that means one of them is legal and one of them is illegal. We wouldn't be in the while loop if they were both illegal. All right, so let's ask the first question. We'll say if pause 1 is less than or equal to middle and pause 2 is less than or equal to end. What does that question ask? That question asks if they are both pointing at legitimate places in their respective lists. Then we need to compare, right? So if that's a true statement, then we're going to ask a question in here. And you can use ands and stuff to melt these Boolean expressions together, but I like to keep them separate, at least when you're first learning this stuff. So my question indented under this one, if I have two legal positions, is if, and the name of my list here is LST, if LST at bucket pause 1 is less than LST at bucket pause 2. If that's a true statement, that means pause 1 is my winner. Correct? Therefore, what am I going to do? I'm going to say, we need to go ahead and give ourselves that temp list. We'll start that guy off as the empty list. Okay, that's where we're going to be storing our answer. So if this is true, we're going to say temp list dot append. What are we appending? We're appending list at pause 1. Then we're saying pause 1 is equal to pause 1 plus 1. Increment pause 1. We picked him as the winner, make him move down his list. Else, if pause 1 wasn't the winner, pause 2 must have been. So we'll say temp list. Go ahead.
What if they're both equal?
Doesn't matter. If they're both 5s, does it matter who we pick?
Right, but shouldn't we? Oh, right, that's an L.
Yeah, we're going to handle the equal sign. Yeah. But you certainly could have said less than or equal to here.
Right.
But then that's technically a little bit less efficient because you would have, the less than or equal to is a less efficient operator than less than. Negligibly, right? But Yeah, we're handling it. We're saying if it's less than, pick it as the winner. Otherwise, pick the other guy as the winner. The other guy must be either greater than or he might be equal to, in which case it didn't matter who we picked. So we'll say temp list dot append LST at bucket pos 2. And then make sure we increment pos 2. That make sense? All right. So that's all the stuff we do if both pos 1 and pos 2 are both legal positions. If they both are pointing at legal places, we got to look at both of them and find out who's the winner. Now, if that's not true, if they're not both legal positions, we know that one of them is legal. All right? Because we would not be in this while loop if they were both illegal. Because two illegals would have failed the or. Or says one or the other or both. But you can't have false or false and get it true. So notice I'm indenting under the outer if here because these two things belong to this question right here. All right, that's another thing. I mean, hopefully we're pretty comfortable with that by now, but pay really close attention to indentation. I know Adam does a lot of it for you, so you don't have to worry too much, but sometimes Adam does indent in the wrong place if you forgot your colon at the end of a line or something like that. You have to go back and fix it. So make sure that your stuff is indented underneath the question or the loop that it belongs to. Okay? So if fails, that means one of my guys is illegal. So the winner is the other one. Right? So now I'm going to ask the question. So we'll say elif pos 1 is less than or equal to middle. If he's the legal one, then we can go ahead and do the pos 1 stuff. Append pos 1, increment pos 1. So this says if pos 1 was legal, default him to the winner. Then we can put an else here, or if you want to be explicit so you actually see the logic, we could say elif pos 2 is less than or equal to end. Then do the pos 2 is the winner stuff. That makes sense? So this is all the logic that happens inside of that while loop. If we're in this while loop, we know that at least one of our positions is a legal position. If they're both legal, find out who wins between the two of them. Otherwise, if the first guy is legal, pick him as the winner. Otherwise, if the second guy is legal, or we could just say else, because the only other condition is the second guy must have won, but just to be explicit with our Boolean expression here, if the other guy was legal, pick him as the winner. Loop back up. Pos 1 or pos 2 has been modified, that particular spin through the loop, right? One of those is one greater than it used to be. Now we'll test this Boolean expression again. Is at least one of them still legal? Eventually, they're both going to walk off the end of their list. This while loop will end. And what will we have afterwards? Let's see. It's still inside the while loop. So this is outside of the while loop now. Let's go ahead and print temp list. So temp list is going to be our sorted lists, but not merged back in lists. Okay. Now, one thing we noticed here in our merge sort, we can go ahead and leave these words here, but did we do anything when end and begin were equal to each other? Besides printing something? No logic occurred there. So actually, what we'll do here is we'll eventually have if begin not equal to end, or if begin is greater than end, do this stuff. So if begin is greater than end, do stuff. Otherwise, do nothing. It's already sorted. If they're the same, don't do anything. That make sense? So I haven't changed logic there. We're taking away some of our extra little print statements that we had going on as we went through here. Similarly, we were printing list parts there. All right, so I'm no longer printing the list parts. We're doing the same algorithm we did before. We just took away the extra little if statement that said, if it's the one list, just say it's the one list. So now we only do stuff when it's not the one list. What do? We call merge sort a couple times, ultimately to get the one list and then start unwrapping the loop, the recursion. Then we go and do our merge step. Okay. Now we can certainly shorten this merge step if we kind of move some of those if statements together with ands and stuff like that. So, but I wanted to keep it pretty separated. So this I think is easier to follow, even though it is longer. So this is the stuff we just did. At the very end, I'm just going to print out a bunch of temp lists. These are not merged back in yet. So what we should see is a whole bunch of different size lists that are in the correct order. Okay, if our pick winner part of our algorithm is correct. All right. So here's our numbers. We'll go ahead and call merge sort on it. What should we see to begin with? We should see, let's figure out what our answers should be here. So we'll do some comments. Initially, we're going to call it on the left half. Then we're going to call on the left half of that. Then we're going to call on the right half. And the right half of that. So the first thing we should see is 2, 3, 17. Right? That's our first merge. Because we're not going to merge this. We're not going to merge this by itself. We're not going to merge this by itself. Actually, we'll see these two merged. So we're going to see 217 first. Then we'll see 2, 3, 17 when we merge this 3 list. Then we'll see 1, 8. Then we'll see 7, 14. Then we'll see 1, 7, 8, 14. And then the very last time through, before we've copied it back, we should see our entire thing merged together, which should be a 1, 2, 3, 7, 8, 7, 8, 14, 17. That look right? So that's our last thing we should see, which appears to be sorted, but we haven't actually copied it back over. So the output of our program right now should be all of these lines. Us seeing the result of the first part of our merge step each time. Oh, don't have a terminal open. Where am I getting 2.5? Is this test? That's test PY, isn't it? Merge sort, call that guy. Begin. Oh, begin will never be greater than end. I was testing you, you guys failed. So as long as begin is less than end, do some stuff. All right. All right. That's still giving me a weird thing. If begin is less than end, we're going to do stuff. We're going to calculate this stuff. Here's my temp list. Temp list is the empty list. Let me make sure this is the right file. That is not the right file. All right, it is. There we go. I was in the wrong directory. All right. this is correct. I just wrote it wrong. So 317 is the first two things we are sorting. Then we had our, I guess 1, 2 would be, I wasted my time doing this. I treated the first half as the 3 list instead of the 4 list. So 317 is the first part. 1, 2 is the second part. Then we merge those guys together. But this looks a little sketchier. So this really should be the sorted version of that. Should be 1, 2, 317. So we have a little bug, it looks like, in our code there. 814, that looks fine. 7, 8, 14. And then merging them back together, we probably have the same bug here. So it looks like we're hitting the right partial lists, but we're not actually sorting them quite correctly. So we need to go look at our logic again for how we're comparing those guys. Because what we're running into here is I'm comparing a 3 to a 1. Those are my 2 sorted lists. Why am I getting a 2 first? Does append add to the front or to the end?
The end.
Append adds to the end. So it should have given me the right thing. Okie dokie. So if list at position pos 1 is less than list at position pos 2. Okay, so this says if either one of them is legal, let's roll. If they're both legal, then pick a winner. If this guy is less than this guy, append him to temp list. Who am I appending? Pos 1. Then increment pos 1. Otherwise, append pos 2, increment pos 2. That looks correct to me. Else, if pos 1 is less than middle, that's the legal guy. Increment pos 1, or append pos 1, increment pos 1. That looks correct. Pos 2 is less than or equal to end. Add pos 2, increment pos 2. And this printing temp list is after that while loop is done, is it not? It should be. It looks like it's getting printed out that way. Pos 1 is begin. Pos 2 is middle plus 1. Yeah. That looks correct to me. Before we do our merge step here, let me do that print list parts from begin to end. So each list should show me the list it's about to try to merge first. Let's make sure that that's happening correctly before we actually do our merge step. All right, it's trying to merge this full list from begin to end. That seemed to come out okay. It's trying to merge this list from begin to end. That came out okay. It's trying to merge this list. Oh, that's interesting. Why is this 1 and 2? Oh, that's from my previous merge step. Oh, we're fine. Nothing's wrong with our algorithm. So of course I was testing you. Anybody know what's going on here? What's the problem? What step are we not doing in our algorithm right now on purpose? We purposely are not doing that step, but yet we're assuming results as if we did.
We're not actually copying temp list into the actual list.
Yeah. We're not actually changing the real list to be our new sorted stuff, yet we're expecting it to have happened. Does that make sense? We didn't write the full algorithm yet on purpose, but now we've thrown ourselves off by expecting it to have magically overwritten that part of the list, and we wonder why stuff is out of order. Why did it look good here, but hey, it didn't change there? Because we didn't tell it to change there. So we need to go back in and actually write our merge step in order to test this. It does seem like we're working with the correct parts of the list. Our logic looks good. We're comparing the right stuff. So let me well, we'll leave that in there for right now. Actually, it's probably not going to help anything. So right here, we should have an ordered temp list. Did I spell ordered right there? Or is it 1 R? Or is it 2 R's? 4 R's? Is it 4 R's? Now, copy back into LST. All right, so this is that tricky part that we assume magically got done this previous time. So now what we need to do is we need to go through. We said we're going to have a for loop that goes through all the buckets of from begin to end inclusive. So we'll say for I in range of begin to end plus 1. That way we also include end. But then we're also going to need a pause. We'll start off at 0 to keep track of where we are inside of temp list. So I want to say LST at position I gets the value of temp list at position pause. Then pause is equal to pause plus 1. That make sense? This will do the actual copying over. So we're walking our temp list through this variable called pause. So bucket 0, then bucket 1, then bucket 2, then bucket 3. But we're walking list through a variable called I. Bucket begin plus 1, begin plus 2, begin plus 3, so on and so forth. So now in the end, after I merge sort numbers, I'm going to go ahead and I'll print numbers beforehand. I'll print numbers afterwards. And this should be the sorted version of numbers with everything copied back over. And there we go. And all those other print statements would have looked more legit this time around because we were actually changing values inside of our array. Okay. Questions about merge sort here. Now, we got a couple minutes here. Let's review some of this real quick and look at it in context. Would we all agree that merge sort was probably the hardest thing we've written so far?
Yes.
Complex, especially if you're not drawing pictures, right? Okay, drawing pictures helps. Now let me ask you this. Let's go back to week 1, week 2 of class, probably week 1. We talked about how human beings solve problems. We remember stuff, we ask questions, we do repetition, right? Pretty simple things, right? And I said that all programming languages, no matter what language it is, provides facilities for doing those 3 things. Remembering crap, that's through variables, asking questions through if statements, and repetition through loops, functions, and now we've seen recursion. That's a form of repetition, correct? Is there anything in any of these lines of code? So let's see, the merge sort itself goes from line 7 to line 34. Okay, so it's not that many lines of code. It's what, 27 lines of code?
Minus 2 for the...
No, whatever. We're in like the less than 30 lines of code. Less than 30 lines of code when you think about operating systems that have thousands and thousands and thousands and thousands of lines of code. This is small, right? as I go through here, so here's repetition, here's variables, here's variables, here's variables, here's conditionals right here. This is all asking questions, asking questions, asking questions. Repetition, variables, our new form of repetition, which was the recursion, variables, asking questions. Everything we wrote here can be broken down into something we talked about week 1 of class. We haven't introduced any weird magical voodoo, right? This is all the same stuff, but we're solving harder puzzles. Okay, we've gone from the little puzzles that the kids are going to have to put the square peg into the round hole and it's not working. Now we got the more advanced, the toddler puzzles, right? Where we're doing a little bit more difficult stuff, and we have to draw those pictures in order to make our lives a little easier. But even if you are writing Microsoft Windows, you're working for Microsoft, you're writing the next version of that operating system, it's going to be the same crap, just more. Okay, so you need to be able to break it down into its small steps. You got to draw those pictures. You got to do those different steps in order to solve the problems. That makes sense? That's why you got to practice. That goes back to your thing of write code, don't read code. That doesn't mean don't read code, but write code over reading code. But draw lots of pictures. Every single one of you right now needs to be drawing pictures for every single assignment. All right, no homework over the weekend. Most of you, hopefully, are doing the hackathon. So make sure if you haven't already done so, you have contacted your teams and are talking about your projects and what it's going to take to hopefully take second place, maybe third place behind my other team. Okay, but Grace and I have already wrapped up first place, I think, right? Yeah. So I guess good luck to the rest of you. But I'll see most of you tomorrow morning at 8 a.m. I don't know, somewhere here in the computer science lobby thing to eat and stuff, and then we'll get rolling. If anybody has had last-minute thoughts that they want to do the hackathon, if you contact me and Dr. Josh Locklear or Professor Josh Locklear today, I probably can put you on a team. I don't want you to miss this opportunity. So consider it.